Okay, so now we're recording. So it's September 26th. This is day 3. So how did that work out last week with the video? So I know I talked to some of you after the video, but was that okay? Okay, so if there's ever a problem with the video, always reach out. I have them on my YouTube channel, so I think they're okay. But if anything were to go awry, just let me know. And if you watch it and you say, okay, that was fine, but it really came at me too fast and I have some more questions, that's fine too. I can hop on with you about that as well. Okay, so what you probably want to do is like print out the notes that I post. So let's look quickly at what I have up on Brightspace. Let me just see if I can get, I think I have it open already. And I do. So let me just share my laptop. Okay, I just want to get out of that. And I'm going to share this and go into here. Okay, so here is our home page. Okay, so here we are. So we're here on the 26th. So the problem set 2 is attached. So Tristan, this is yours, where it says MAT 546. Okay, this is everybody else's. So in terms of posting things, Tristan, I couldn't make it any clearer. Okay, this is Tristan's. This is a different assignment, and this is everybody else's. So this is what you're going to see. So I know that I've graded one already, and I've sent that back, so you can see what I said on it. And then I know 2 more have come in, so I'll probably grade those either tonight or tomorrow, and I'll give you feedback on that as well. So I think you get notified when there's feedback. Here is your next problem set. This is on all of chapter 2. So you're going to know only a little bit of it tonight. So it's always a good idea to kind of look at the problem set and say, okay, what did we learn tonight that I could probably figure out? And what do I still have questions on? Because we're going to only do sections 1 to 4. So this is what you wanted to either, however you do it, print it out, download it. If you have an iPad, you can just take notes on top of it. I use Notability on my iPad, which is fabulous. So that's how I do it. But so we're going to go through this. And then I try to put other things up here. So the first reflection paper is due class 4, which is next week on the 3rd. And I believe I already have a site up there to attach it. I'll look at that in just a second. Problem set number 2 is due class 5 for everybody. So they're already up and posted. So let's look at what it looks like for class 5. So if I go into class 5, here is where your problem set 2 is going to go, unless your name is Tristine, and then you're going here. Okay, so that's the problem sets. And I need to, hold on, I need to get here. Here's a reflection paper. So Tristan, even though Christine, even though your reflection paper is different, you can still put it here. Okay, and then here's the video for next week's classes when we'll go over sections 5 to 8. So section 9, we're going to do October 10th. It's called piecewise functions. I will tell you that on the test, which is the 17th, that will be a bonus question. Okay, so piecewise functions will be a bonus question, and we will cover it in class here, and we'll also answer any questions you may have on anything else. For the 31st, what if we meet, instead of on Tuesday, can we meet on Wednesday instead? Same time, November 1st, would that work? So then this way, you know, if we have a lot of doorbells, if you're taking your own kids around or you're doing something in the neighborhood, you can still do that, and we can meet on the November 1st. So I will change this up here, but I wanted to just check with everybody first and see if that would work. So I will change that when I have a sec to go back on that, but just know that that's what we'll do. Okay, hang on one second. Okay. Alicia, you are an over. So you did both problem sets?
I did, because I didn't know that one was hers, but it's fine.
So you had tons of practice.
I did. I did. So it was
Read
fine.
that question.
But now I know this week. Yes. So I'll just do one. I didn't know. So
Yeah,
I
that's
just made sure I got them done. But
right.
the extra help was good. So
Okay, good. Very good. Okay, so then so yeah, so think of Angela, think about 11:1. You can get back to us on that. You know, I can always I will always record it anyway, so you'll be okay with that. But let me know because we can kind of fool around. My husband's birthday is 11/2, so that's probably not a good day. And we also have the option of doing it Monday instead. So we can make a decision. We have time still. So look at your calendars and then we can discuss this again. Okay, so let me stop sharing here. And I'm going to go into my iPad where I have the notes. Okay, let me just get it set up and then I'll share screen. Okay, so you definitely need a calculator for this because there is some calculations when we go over the first problem has some calculations, but that second problem, which is problem 13, and it has all kinds of pieces to it, that definitely needs to have a calculator. So let me share screen and I'll go back to the iPad. Okay. All right. So this is what the notes should look like. Okay. So that you should, can everyone see okay? Because I just updated my Zoom today. It's actually a lot clearer finally. But it also like has a little delay where it tells me, okay, you are now sharing the screen. And it gives me a little picture of it. So it's kind of interesting. But we just did that. We're doing parent-teacher conferences and we have Fridays are on Zoom. So we had to update things. So anyway, so big picture on what we're doing right now. Chapter 2, we do a lot with average rates of change. So if you're dealing with a line, know that the average rate of change will be the slope. They don't tell us that until we get to section 3, because you can figure out an average rate of change on things other than a line by just superimposing a line on any function. So that's what they talk about initially. Just you're going to be given some points and you will calculate the average rate of change. So in 2.1, so big picture, in 2.1, they talk about average rate of change. We're going to do these kind of problems. Then they talk about in 2.2, the change in the average rate of change. So if you look at like a graph like this, you don't have a constant slope because there's a change in the average rate of change, which is the slope. Okay, so that's the next piece of it. So we have some practice problems there. Then they say the average rate of change is a slope. It's either the slope of a line or a slope of a line that you are imposing on top of a function. So they tell you that as well. And then the last section, the 2.4, talks about how misleading data can be. Depending on where you look at your data, you can tell a whole different story. So that's an important thing to know, because as a teacher, you want to know, you want to be aware of what you're looking at, how the X and Y axis is structured, what the title is, and what they're really telling you, and what assumptions you can make. Okay, so that's the big picture about what we're doing tonight. So hopefully this is not making you dizzy, but we're coming back here. Okay, so average rate of change with respect to X. Okay, so that's the key. You're going to talk about how Y is changing with respect to X. Just like when we talked about increasing, decreasing, you talked about how Y is changing with respect to X. So X kind of tells the tale of what's happening to Y. Okay, so here is your equation that we're going to use. It's change in Y over change in X. If you're given, for example, if you're given an X and a Y, so you'd be given 2 points. So a lot of times they'll say this is X1 and Y1. And this would be x2 and y2. So instead of just saying change in y, they may say y2 minus y1. If you put y2 first, then for your denominator, you've got to put x2 first. Okay, so it doesn't matter the order, just as long as you're consistent. If you prefer to say y1 minus y2, go for it. But then you have to say x1 minus x2. Otherwise, you will not get the right answer. Another way to express this is with a delta. So like a chemical sign. So change in y over change in x. Okay, so there's many ways of speaking about that. But those are the main ones that you'll see. And in terms of naming things, okay, the numerator is the top. The denominator is down, so it's the bottom. Okay, so if you're putting this in your calculator, if you have a calculator that gives you a little box with a numerator and a little box with a denominator, you are good to go. If not, if you have two terms, you've got to put them in parens if you're doing a division sign in between them. So you've got to be careful about that. And we can talk about that in this first practice problems. Okay, so here they talk about the limitations with the average rate of change. And so there's a subtle thing that's going on here. It says, note that the average rate of change depends upon the endpoints. If the data points do not all lie in a straight line, then the average rate of change varies. So the average rate of change is only constant if your data is a line. Otherwise, depending on what snapshot you take, you'll have a different rate of change. Okay, so it'd be normal to expect that the rate of change changes unless they tell you your function is a line. Okay, so this first problem says your car's gas tank is full and you take a trip. You travel 212 miles. Okay, miles is kind of like time. That is your X variable. Then you fill your gas tank up again, and it takes 10.8 gallons. That's your Y. If your change in distance is 212 miles, again, that's your X, and your change in gallons is 10.8, that's your Y. What is your average rate of change of gasoline used? So gasoline is going to be in the numerator, measured in miles per gallon. Miles are your X, gallons are your Y. So it's going to be change in Y over change in X, and that's change in miles over change in gallons, the way they're telling us how to do this. So let's see, I just flipped it for you. So yeah, they're saying, so let me switch this. They are saying the opposite of what I just said. So let me just switch that back around. They're saying that your miles is the Y and your gallons are the X. And that's true because your gallons are triggering how many miles you're able to go. So that's your Y, that's your X. Sorry for that confusion. That's your Y, that's your X. And you can tell if they're saying miles per gallon, this per means over. So you want miles on top per gallon. Okay, so they told you the change. They didn't tell you the 0 minus whatever. They're saying the change is 212 miles. And the number of gallons that you use is 10.8. So you wouldn't leave your answer like that. Okay, that's going to be put in your calculator now. So take your 212 and divide by 10.8. And because this is rounded to the nearest tenth, I'm going to have my answer to the nearest tenth. and I'm going to get 19.6, and then you're going to call that miles per gallon. Okay, so that's a pretty straightforward problem. And if you're going to be graphing this, the miles would be here, and the gallons would be here. And this would be your Y, and this would be your X. So the gallons is independent, and the miles depends on how much gas you have and what your gas, how efficient your car is. Okay, the next one I'm going to have you kind of do in groups. So I can break you up into groups and you can talk about this, because last time I just talked the whole time, and that was good for the first time because we had a lot to go over, but I want you to be able to talk to each other. So I'm going to set you up for success, and then I will put you in groups, and then we'll come back and see how we did. So I'm going to do the initial calculation for the all category. So I'm going to tell you how we're going to do this. So this says, this chart's giving us the percentage of persons 25 years old and over who have completed 4 years of high school or more. Okay, so you need to figure out the rate of change. What was the average rate of change in percentage points per year of completion of 4 years of high school from 1940 to 2008 for each of the categories? So we have white, Black, Asian Pacific, and then the combined all category. So if I'm going to do the all category, I'm going to show you how I'm going to do my calculations. So I want to figure out the percentage, the average rate of change. It'll be in percentage points because these values here, all of these are percentage points. Okay, so that's one thing. You've got to figure out what you're looking at here. So to do all, I'm going to do my change in Y over change in X. X is your time. Okay. So I'm going to do 2008 minus 1940. So that means that I have to do, if I'm going to do the all calculation, I'm going to do 86.6 minus 24.5. So that's going to be my rate of change. So when I put this in my calculator, if you're going to put it in, so let me show you one thing quickly. So I have those values written down someplace. So when I stop sharing, I want to go into the calculator and show you what I mean about putting it in carefully. Okay, let me just go back to share screen and grab the calculator. Okay, so here's my calculator. So I don't need the data feature anymore. So I'm going to get out of that. And I just want to get back into the numbers. So let me just say clear. And that's, whoops, I want to clear everything. I want to get out of that. Okay, let me go back out. So how do I get out of this function? Let me see. Oh, okay. Let's see. Okay, maybe I'll do this. I'm going to go second quit. Okay, so what I did, I said second quit, and now I have a blank screen. Okay, so the second key is here. The second's blue. The blue controls all the blue keys above. So now I have a nice blank screen. Now, this calculator, I can do alpha y equals, and I get a fraction bar, which is great. So if I have a fraction bar, what I can do is in the numerator, I can say 86.6 minus and it was 24.5, 24.5. Okay, and then my denominator was 2008 minus 1940. Okay, so if I have a fraction bar, I can just pull out of the denominator and hit enter. And that's what I'm getting. 0.9, 0.91 is what I have. So that's where I am. I have this, my mode right now must be intense, and it is. See where it says float? So I'm going to make it into hundredths. And I'm going to say second quit. And I'm going to hit enter. And that'll put it, but would have put it in hundredths. I don't think it held. Okay, so my point is, if you have a fraction bar ability, I'm good to go. But most of you probably will not have a fraction bar ability. So in that case, because you've got two terms in the numerator and two terms in the denominator, what you need to do is say paren 86.6 minus 24.5, close paren, divided by, open paren, 2008 minus 1940. Close paren. Enter. Okay, you'll get the same answer. Without the parens, PEMDAS is going to kick in, and you're not going to be doing exactly what you want to be doing here. So just be aware of that. Now, after you do this, a lot, this year down here is always 68. So once you see that, you can put parens here and then just say divided by 68. And then you're good. Then you wouldn't need parens in the denominator. But if you have two terms, if you have two or more terms, you have got to put the outside parentheses in so that you do the division correctly. Okay, now you may have all known that, but I'll tell you, that's where my algebra and my pre-cal kids will mess up if they don't think about the parentheses. Okay, so any questions about the calculator? Okay, so let me do this. I'm going to say stop sharing, and then let me see if I can go into, let me end this. Hold on one second. Okay, so why don't we do like 2 breakout rooms, and I'm probably going to be put in one, but so you should be able to talk to each other and see if you can do the whites, the blacks, and the Asian Pacifics, and see what numbers we get. Okay, and then we'll all come back. So let me create, I think you may have to accept. Just look on the screen, see what they want you to do. Okay, I'm going to open all the rooms. Okay, so I'm not in one, so I'm going to open the rooms now so you can join. So I think you need to join your room. Is that clear? Yeah, there you go. And once you join, you disappear from my screen. Okay, so I think we're all back. Okay, good. Okay, so just checking in, it sounded like we were all getting the same answers. So so what did Trish, what did you get for white?
We got we rounded it to 0.9, 0.89. But
Okay, is that good with everybody on the other group? Okay, and then I think I talked both of you with blacks is 1.11-ish. And then Asian Pacific was 0.97. Does that seem good? Okay, so everyone knows how to do those calculations. So they ask you some more engaging questions to kind of think about how you can use average rate of change. So I'm not going to have you all do it because it'll take a lot of time, and I want to make sure we get through all the notes. This is already almost 7 o'clock. So in terms of B, it says if these rates continue, what percentage of whites, of blacks, of Asian Pacific Islanders, and of all will have finished 4 years of high school in the year 2010? Okay, check the internet to see if your predictions are accurate. Okay, so we're not going to check the internet, but we know that the data is so far up to 2008. So I'll tell you what I did. So to set it up for the all, what I said was, okay, we calculated that the all was at, they gave us, the all was here. So the all was at 86.6 in 2008.
Are you writing on your notes?
Oh, I'm so sorry. Yes, I'll
Sorry.
share the screen.
Yeah.
Thank you, thank you.
Yeah, sure.
Much technology sometimes. Hang on. Okay, so I'm sharing, coming in. And we have successfully arrived. Okay, so what I want to do is just show you the setup. So to calculate all for this, to figure out what's going to happen in 2010, you have your initial percentage that are going to graduate in 4 years. We calculated that, let me just turn this on again, hold on. We calculated that every year, if we're going to average it, that 0.91, if you do it at that rate for 2 years, what do we get? And I end up getting 88.4%. So if we had this completion rate, and then we said the growth rate between 1940 and 2008 was 0.91, if that happened for 2 years, then I would say 2 times 0.91, I would add that to the initial 2008 numbers, and I would get in 2010, 88.4. So that's how you work that through. So similarly, let me just do Asian Pacifics, just to give you 2 data points. Asian Pacifics, we started out saying in 2008, it was at 88.7. Then if you are going to change, the rate of change is going to be the same as what we just calculated between 1940 and 2008, then I would say 2 times that 0.97 added to what we initially had, that gives me 90.64. So that's the approach with B. So you're going to use your percentage increase, your average rate of change, and you're going to say it's going to be constant. Now, notice you're making all kinds of assumptions, but making the assumptions gives you some insight into what could possibly happen. Many things can change. That's why they said, check the internet, see if our predictions are accurate. But that's the setup. So then look at the next question, because that's a little bit more complicated. For this next one, what they're saying, if these rates continue, so if these rates continue, what you just calculated, in what year will 100% of whites have completed 4 years of high school or more? And they want the same thing for all of them. So what I did was to do what? So I want to figure out what year this is going to happen in. So I'm going to make my year X. So some number of years times, and this is I'll do whites, since that was the first one they mentioned. Some number of years times the growth, the average rate of change was 0.9. So this has to happen for a while. Add that to the original rate in 2008, and that has to equal 100 because they want it to equal 100%. So in order to do that math, what you're going to do is you're going to say, okay, this is like this kind of algebraic problem. 0.90x plus 87.1 equals 100. So you want to isolate your x. The first thing you're going to do is subtract away the 87.1 from both sides. And when you do that, so I'm going to just say in my calculator, 100 minus 87.1, and I get 12.9. So 0.90 times some number of years has to be 12.9. So 12.9 divided by 0.9 is going to equal, it's going to take, to reach 100%, that's going to take 14.3 years. Okay, so that's the setup. That's a little algebra. So you would do that for each of them and see how many years you would get for each of the different categories. Now, getting to 100% graduation for anybody is very unusual. So your projections don't really make sense because things always change over time. But this is how you would do it. If all else equal, the pattern continued, you'd have to figure out how long it has to continue for, that's your X, to make 100% rate of graduation, 100% completion of 4 years of high school. Okay, so that's the setup. So there's 3 different problems. The first one is just straight rate of change, average rate of change. The second one is using that to figure out as a predictor of what's going to happen in 2 years. Then the next one says, okay, I want to get to a certain percentage. How do I use this information to get there? So that's the setup. So I just wanted you to be able to see that because this is when it kind of gets interesting that you can be predicting some things. But remember, with all predictions, there's a lot of underlying assumptions which may not hold true. But the math of it is here. Okay, so that's all of 2.1. And that just really has to do with average rate of change. The big takeaway is that the overall understanding is that you're going to change the change in Y over change in X. Be careful about using parens. Make sure you're consistent with what you put first. If you have 2 values, make sure that you have it set up like that. Okay, and if you don't have a bar on your calculator that you can easily distinguish numerator from denominator, you have to use parens. Okay, those are the big takeaways. So then they start talking about other data and they say, okay, what if you have a shape like this? You don't have a constant annual rate of change in US population at all here. So every decade is going to kind of, go a little different. So perhaps you might have a little bit of a straight line right here, but look, you have a straight line down here, and then you're up here, you're down, you're up, you're down. Okay, so there's a lot of things going on here. So if you look at this data, you can see some things. Between 1940 and 1960, this was your baby boom. Okay, clearly there's been a very big increase in the population. That's what's happening there. So then you also have, the depression. So you have depression going on over here, You've got wars going on. All these things have an impact on population. Now, if you try to figure out the average annual rate of change, and you go from, say, 1980 to 1990, you'd be drawing this straight line. That's a very wide range of years. That doesn't really capture what's going on. So the bottom line is, depending on where you are looking, from what period to what other period, you may not be telling a clear story because the rate of change is going to be different. So let me erase what I just did so I can talk about something else here. So if I looked and I wanted to say, okay, in general, this is what the population is doing. If I look from 1960 to 1990, I would say the rate of change was negative. But if I look from 1940 to 1960, I would say the rate of change is positive, very positive. Here it is, a drop again. So depending on where you look, you will have a different analysis. And you want to be aware of that. It's not a straight line. It's not constantly increasing. What's happening is the average rate of change is constantly changing. And that's how that works if your data is not just a straight line. So then they go on to another table over here. And they say, okay, calculate the average rate of change between adjacent points for the following table and place the values in a third column. So the reason why it's not applicable here and here is I don't have 2 years, okay? That's my starting year. So you would say, this is your X. Remember, your f of X is function notation for your Y. So to get your average rate of change, you would have said change in Y over change in X. Maybe I can make my little thing bigger. And so I'm going to say 25 minus 5 over 10 minus 0. So that's going to be 20 over 10 or 2. What I'm going to see for this is that as I do that calculation, so for the next one, I would say change in Y over change in X would be 45 minus 25 over 20 minus 10. And I'm getting 2 for that as well. So if you do all the math, you will see that the rate of change is constant at 2. That means that this data must be a straight line because my rate of change is always the same. So what does it look like? Well, if it's positive 2, my slope is going up. It's going up in a positive rate of change because that rate of change is my slope. So here's my f of X, here's my X, and I have a slope equal to 2. Positive slope. As I go from left to right, what's happening to my function is it's constantly increasing. Okay, so constantly increasing. As opposed to this g of X function, when I do the g of X calculations, what I see is the following. I'm going to start again at the second row, and I'm going to say change in Y over change in X, and that's going to be 240 minus 270 over 10 minus 0. I'm going to get a rate of change, an average rate of change of -3. That's going to be consistent all the way down. That means that I have a line, and this time my slope is going to be negative. Okay, so this will be my g of X function, and this is my X, and my slope will equal -3. So throughout the function, as I move from left to right, from an X of 0 to an X of 50, my values of the g of X go down. And the rate of change is -3. So the slant of my line is the opposite direction from when the rate of change was a positive number. So here's the increasing, decreasing constant. Okay, if your slope is positive, so your f of x is always increasing. Whereas my g of x is always decreasing. So is the average rate of change, so is the average rate of change of each function increasing, decreasing, or constant? It is constant. Okay, the change is the same between every pair of numbers. Okay, you have a constant rate of change. So then they give you some different scenarios. So it says each of the following functions has a graph that's increasing. Okay, so is that true? As you go from left to right, are you going higher on the y's? And you can see that you are, right? If you're going from here to here, I'm going higher on the y's. Here to here, higher on the y's. Here to here, higher on the y's. So then I know that it is true that the function, the graph is increasing. If you calculate the average rate of change between sequentially equal size intervals, which function can be said to have an average rate of change that is constant? So if your average rate of change is constant, which one do you think it's going to look like? Any takers?
Would it be B?
Yeah, because
That's
you're
what
going to constant slope. Okay, so this is going to be constant. So constant is going to be B. So that's a constant rate of change. Because if I draw a tangent line to this function, it's always the same line. Now look, if I draw a tangent line to this function, I have that slope there, but I have this slope here and that slope there. So it's getting steeper and steeper and steeper. So this is increasing. As opposed to this one, my function's still going up, my y value is still going up, but the average rate of change is slowing down. So that's going to be decreasing. Okay, so that's what they wanted to cover in this section. Can you recognize when you have a constant rate of change? So this constant one, I'm going to say see table above, because we calculated the rate of change and it was always the same. So therefore the slope is the same. It's a constant slope. So that brings us to 2.3, when they suddenly tell us that this really is slope that we're talking about. So here's your equation for slope. As I said, it doesn't matter as long as you're consistent. You may want to do y1 minus y2 versus y2 minus y1. It doesn't matter as long as you are consistent. So then here they want us to think about this. So think about the side of a slope of a line. If the slope of the line connecting any 2 points in the graph is positive, then the output increases as the input increases. So what does that mean? If we're going to do this, if the slope connecting any 2 points, so if I have this point and this point, and if I connect that line like this, then what's going to happen is, as I increase my x, I increase my y. Remember, your x is your input, and your y is your output. So that if the slope is positive. If the slope is negative, and this is your y and this is your x, which way is my slant going to be? So down, right? So I'm going to go this way. So here are my x's. As I move to the right on my x's, what's happening is my y's are going down. So the output decreases. Now, if the slope is 0, that means that you have a situation like this. It doesn't matter how much x you put in, you get out the exact same y. So the slope is 0 because change in y over change in x, since x is changing, that'll be some number. But since y is not, that'll be 0. And 0 over a number is 0. As opposed to the last scenario, if the slope is undefined, the line is vertical. Okay, so this line was horizontal. If the slope is undefined, the line is vertical, it's going to look like this. So that line is vertical. And think about let me make that look a little bit better. Think about this. If this is your y and this is your x, and you want to figure out the slope, which is change in y over change in x, well, as you move from point to point, the y is going to change. That's going to be a number. The x is not changing. That's a 0. You can never divide by 0. That's what makes it undefined. When you try to apply the equation for slope, you'll be forcing yourself to divide by 0, and you can't do that. Okay, game over if you try to divide by 0. So that's why vertical lines have undefined slopes. That's the hill you can't run. Okay, so there's only 2 more little things. I was going to have you do little group stuff here. See if you can calculate these slopes. So you have A, B, and A and B. So you're going to find the slope. The slopes will always be the same number because they are lines. So why don't you just quickly try to do that? Take like 5 minutes and I'll call you back. So I'm going to stop sharing here and put you there so you can talk about that. Okay, so go ahead, you can join your room. Okay, it looks like we're all starting to come back. So let me just see. Yes. Okay, so what are we getting, and did it make sense when you actually tried to do the math? So for that first graph A and problem number 2, what are we getting for a slope there? Anybody get to that? So I think what I said was I counted and I said that this is going to be 0. Oops, sorry. That is going to be 0, 4, which is the y-intercept, and this is 3, 0. So if I do that calculation, change in y, I would do 4 minus 0 over 0 minus 3. So I'm getting -4/3. Does that make sense? So just pick your points that you can read. And that is consistent with my view of it. It is downward sloping, so I would anticipate a negative. So I have a negative. So then this one, because the top one is 8, I've got 1, 2, 3. So this is 0, 3. Remember, when you have a coordinate pair, it's going to be x, y. So that's 0, 3. And this is -4, 0. So change in y over change in x will be 0 minus 3 over -4 minus 0. So that's going to be a -3 over a -4. And don't let that throw you off, because negative over negative is a positive, and that's consistent with what my view was, that it's a positive 3/4. Okay, so I have a negative and a positive. Okay, here I can see the slope is going to be 0, and I can prove it to myself. How would I do that? I would say, okay, this is a value right here. My x is 0, and my y is 1, 2, 3, 4, -4. So then I go over here, and I say, okay, what value is this? Well, I still have a -4 for my y, but now I have a 3 for my x. So if I say change in y over change in x, I'm going to say -4 minus a -4. That's going to become -4 plus 4. And then I have 0 minus 3. So I have -4 plus 4 is a 0 over -3. It doesn't matter whether it's -3 or +3. Your slope is still 0. And the last one, in terms of these points, this is 2, 0, and this is 0, -10. And you should get a slope of a +4 there. Sorry, this is 0, -8. That's why it's +4. That's an 8. Okay, so that's going to give you 8 over 2 or 4. So the slope is +4. So your calculation should match what you're seeing. Anybody have any worries about that? We okay? Okay, so the last thing we're going to do is talk about putting a slant on data. And this is, you can make data tell any kind of story you want. And you've got to recognize that. So if you have this situation as a poverty graph, depending on where you look, you can talk about poverty going up or going down. Okay, if you're going to go from this point to this point, poverty is going down. That's good news. If instead you focus here to here, poverty is going up. Not so good. It depends on where you're looking. And that's why data can be very misleading. The classic scenario is this one down here. These three graphs in these squares are all the exact same data. But depending on how you set up your X and Y's, you can tell very different stories. And so it can be very misleading. Here you go, oh, there's a slight little growth in population for the first one, but now you go to explosive growth and then kind of a reasonable growth, but it's all the same data. So be very focused on, if you're comparing data, are you comparing apples and oranges, or are they kind of playing around with your axes? So you want to really focus in on that. And even when you read things, I mean, it's amazing how, you know, the data can be manipulated. And as long as you're aware of that, then you're not as easily manipulated. Okay, so then here's another scenario here, same thing. It says, compare the accompanied graphs, which appears to have a steeper slope. So this one definitely has a steeper slope. But when you actually do the math and you figure out the change in Y over the change in X, this I have a -6 is my slope. If I do the math here, change in Y over change in X, that's going to be a -4. So this appears steeper, but is actually not. So again, if you're going to have people interpret slope, if you do the math yourself, you might see that what they're saying may not be true. So just be aware of that when you're comparing things. Don't just go by how it looks. You got to do the calculations as well to figure out what you have. Okay, so a little quick vocab. Where your graph crosses the y-axis, that's called the y-intercept. Okay, so here it is over here, the y-intercept. Where it crosses the x-axis is called the root. Because that terminology will be coming up. So I thought this is a good time to mention that. So that's it. We got through the 4 sections, 7:27 record time. So you should look at that second problem set and see what you think you can do based on what we did today with average rate of change. So the focus was all average rate of change and calculating slope, and how if you have a curve that's not a line, depending on where you pair your data, you will get different results. And so remember, when you put things in your calculator, if you have multiple terms in a numerator or a denominator, make sure that you use your parens. Okay, so you can get that correct. So anything for the good of the cause? So I can post this video as well. So I'll post it in case you want to go back and listen to anything, it'll be there. And then next class, we were going to do a video lesson. But see what you think. If after you listen to the video lesson, you think, okay, I have some questions, then email me and I'll reach out and we'll figure out a time that we can go over things if need be. Okay, so don't be shy about that. Look at your calendars, figure out what the best scenario is for Halloween, and we'll talk about that again when I see you. So you're going to do the 2.5 to 2.8 on your own with the assistance of my video. And then we'll come back and do a review, and I'll show you piecewise functions. The piecewise function piece will be on as a bonus. So it'll be good to understand it, but it is a little bit confusing initially. So I thought that's a good way to handle that, because I don't like to have like the class and then the next thing is a test on something I just taught. So really, after you listen to the video next week, see if you can do the rest of the packet and see where you are with that, so that when we come together, you can ask me questions and feel like you're getting prepared well for the upcoming test. Okay? All right, well, we did it. Well done, ladies. So let me know how things are going. Those of you that submitted your problem set already, I will get to that this week, and I will send it back to you with my comments and my grades. So I should tell you that you can always get a 10.5 on that problem set. Everything has a rubric on the very first page. The way it's set up on Brightspace, I can only write into you in the grade book there a 10. But I will tell you in the document if it's a 10.5, and in my grade book that I do separately, it goes into the 10.5. So know that that's just how that works, but you'll always know what you have. And I will like write out things. If there's a problem, if something was incorrect, I will write out and let you know. Let me just check this chat. Okay, yeah, go ahead, ask me about the paper.
Can you clarify what I'm actually supposed to do? So I
Yeah.
see the citations for the article. I just want to make sure I'm understanding.
Yeah, so you need to have citations. Because those citations really weren't well done on the paper itself, I wrote up a separate thing for those citations. For this particular comparison, you only need those two papers. So you're pretty much going to cut and paste the citations that I'm giving you as your citation page. Then your job is to talk about, you can compare and contrast both of those papers. See what you found valuable about it, see what connections you can make. So if you look in the rubric, let's just talk about that for a second. So you're going to get appropriateness of selection because I'm telling you the articles, organization of paper. So are you having a clear, flow of your thoughts through the paper? What's your spelling, grammar, that kind of stuff like? Have you summarized, the articles? Like, give me some general summary. And then in terms of the second piece of it, it says evidence of personal reflection on the content of article. So what kind of resonated with you? What did you perhaps disagree with? What had you already thought? The same thoughts? Had you seen that someplace else previously? Evidence on personal reflection on implications for your own practice in the classroom. Does that change something that you would do in the classroom based on what you've read? And then the last thing is personal reflection on the focus of the article as it intersects with the standards for mathematical practice. So you've got to think about that. We're doing the content for grades 4 to 6. Operations and algebraic thinking is the example here. But if you know what your content is for your lower grades, you would reflect upon that. So you've got to tie it into standards. If your school uses different standards, use that. If it uses Common Core, use that. Okay, so personal reflection, how you're going to use it, what resonated with you, and has it tie into your standards. And then an overall summary. So it shouldn't be like an Opus Dei. Like it should be maybe, no more than like 4 pages, I would say.
Where's the rubric? Because that's what I'm having a hard time.
Oh, so in the course description, there's a topic that says journal article reflection papers. And you want to read that over first so that you have a good idea. So there's a rubric for the problem sets, and then there's an appreciation rubric, and then there's the journal article reflection papers. So that's what you're doing using those 2 papers on algebra. That's a journal article reflection paper. So it's about like on page 5 or so of the syllabus that's posted. 1,
Okay.
2, 3.
So it's in the actual syllabus.
Yes.
Okay, that's why I'm not finding. I'm looking for a tag. But the article that we're going to be using is the one that you have, articles 01, the Krigler.
Yes. So there's 2 of them. They're 2 algebra articles.
All right. So what is the second one? I see the citation. I see article 01. And then I see the Vinnie Bush.
Yes, so there should be two. Let me just stop sharing here and share on my laptop again. So I want to go here and let me share that. And then let's go back to, I think it was September 12th. So there are your citations. So then here are the two articles. This is one article. This is a second article. Okay, and then these are the citations. So just cut and paste exactly like what you have here. If you open up the syllabus, which is here, let me just see if I can get to the page. So I have to move this one. Okay, so that's citations. Let me see if I can do that. I want it to go down, I guess. So when I opened that, when I open this, then I have to slide down. Right? Yeah. So I'm sliding down. So here is, that's the problem set rubric right there. And it's different for every problem set. Here's the appreciation paper. Here's the rubric for the appreciation paper. That's when you use that other textbook, and you have to have at least 2 other references besides that. But what we're doing first is the journal article reflection paper. So here's the rubric for that. So this is the first part. Everyone's getting this because I've selected the articles for you. Then you can get as high as 4 points for each of these categories. And for these 3 categories, it's 8 points. So that means that it's going to be a 40-point assignment. Okay, so that's the whole rubric. And then you always want to have a page, reference page. And I gave you the correct format for it. So you're just going to cut and paste it. And then here's the rubric for the presentations. When we do that at the end. Okay, so that's all there for you. Okay, and then you can see the breakout of the problem sets versus the presentation versus journal articles versus the tests. So that's all there too. Okay, does that make sense? Thank you for asking that, because I think that probably was helpful to everybody. Okay, anything else I can help you with or talk about? Okay, well, I'm going to let you go back and have your own evening, but I will post this video as soon as it loads, and it'll be up on today's date if you ever have to look back at anything. Okay, so I'm going to stop sharing here. So thank you very much, and then we'll check back. Let me know how the video went for next week, and if you need any extra support, we can do that. And then otherwise, I'll see you in 2 weeks. And by then, we need to finalize the whole Halloween thing. Okie doke. Okay, well, have a lovely evening. Thank you for coming on.
Good night.
Bye-bye.